Okay, guys, here's another question for us to solve. The question is this: the period of vibration of a liquid drop is given by T equal to K A raised to power X, rho raised to power Y, tau raised to power Z, where K is a dimensionless constant, A is the radius of the drop, rho is the density of the liquid, and tau is the surface tension, whose dimensions are mt raised to power minus 2. Use dimensional analysis to find the values of x, y, and z. Of course, this is taking us back to dimensional analysis, major use of m, l, and t. Okay. Of course, they helped us to make it easier by giving us the dimensional value for surface tension. Now let's see how we can do this quickly. Okay, guys, first of all, we write out the expression given to us. K A raised to power X, rho raised to power Y, and tau raised to power Z. We'll try not to confuse Z for 2. That's why I prefer putting a dash across my Z. Now, the first thing to take note of is K is a dimensionless quantity. It's a dimensionless constant. So when you have a dimensionless constant or a number in an expression, its dimensional component is just 1. So what that means is we can easily write this as A raised to power X, rho raised to power Y, and tau raised to power Z, because K does not contribute in this expression. Now, to make dimensional analysis, guys, it involves only the basic quantities and their dimensions. And the most common three are mass. In dimensional analysis, you use mass as capital M. Any linear distance, or in fact any distance, length, width, height, okay, distance, displacement, even perimeter, circumference, you use capital L. Then time, use capital T. This is the main thing we're going to do now. So whatever we see mass, we replace with this. Whatever any form of length, we replace with this. Any time we put this. So we are told that time, which is period, is T already, so there's nothing to change. Now this A, we are told it is the radius. Of course, radius is a length, is a distance. So we put it at L raised to power X. Okay. Now, we need to now ask ourselves, what is density? Density is mass over volume. Okay. Which is mass over, what is volume? Volume is length times breadth times height. They are all lengths. So that means L times L, L times L times L. So we have density as M over L cube. So in place of density, we come in here, we put mass over L cube, all raised to power Y. Now, tau, which is force per length, we've been told it is M over T raised to power 2, all raised to power Z. Now let's see what we're going to get. So we have T here, okay, equal to L X this L raised to power 3 is under, of course, using indices, the power here with another power they're going to multiply. But because this is denominator, it becomes minus. So we have L minus 3y. Then for this, we have m raised to power z. Then t squared is denominator. When it comes up, you're going to go with minus. That will be t raised to power minus 2 multiplied by z. It's going to be t raised to power minus 2z. Okay, I hope it's clear what we are trying to achieve. Now we're going to collect terms of the same base, and since they are multiplying, we are going to add their powers. So let's say t on the left side is equal to, let's go for base L. This is L here, this is another L. The first part of L is x. Since they are multiplying, we are going to add their powers. That means plus minus 3y will be minus 3y. The next base is m. We go for m. First power is y. Since the m's are multiplying, we add their powers, y plus z. And lastly, the t. And there's only one term of t, minus 2z. Now here is where it gets interesting, guys, and you have to pay attention to that. What we are dealing with here is an equation. Equation means everything on the right must be equal to everything on the left. Now let's check if that is possible right now. For t, they have t on the left, we have t on the right. Okay. But look at L. We have L on the right, but we don't have it on the left. How can we introduce L on the left? Because we must balance every symbol and its power. I'm going to say t, since there is no L, you know that any number raised to power 0 is 1. That includes letters. So L raised to power 0 will give you 1. 1 times t is t. So I haven't changed the question given to me, but I just introduced something that's going to help me sort it out. Now check on the right, there is n. But on the left, for it to be balanced, there is no n. Let's introduce base m. But from the original expression, there is no m on the left. We know as well a number or letter raised to power 0 is 1. So we raise the power of m on the left to be 0. Notice I didn't change anything. M to power 0, 1, L to power 0, 1. 1 times t is t. So I'm still in order. So now it must be equal to L raised to power x minus 3y. M is power this and that. So for this equation to be possible, all on the left must be equal to all on the right. The easier way to start is, first start with the base with the least complex power. And if you like, check t has the least complex power by the right. So I'm going to say 4 times t. On the left, I have t raised to power 1, because you know any number raised to power 1 is that number. Okay, I will neglect everything about L and M and concentrate only on t. Now let's go to the right. What do we have for t? T is t raised to power minus 2z. It means t raised to power 1 must be equal to t raised to power minus 2z. For that to be true, their powers must be equal. That means their bases are the same. So we can eliminate the same bases. When I equate their powers, 1 is equal to minus 2z. Since we are looking for z, we divide both sides by minus 2. So we say that z is equal to minus 1 over 2. With that, we've been able to get our z. Now let's go for the next power. Now, since we have z, if you check for L, it has something to do with z. But look for M. M has to do with z and another unknown power. Of course, we've gotten z, so it's easier to use the known z to find y. So we say 4m. On the left, m is 0 equal to, on the right, m is y plus z. For the two to be equal, we cancel out their bases. It means 0, we put the powers, y plus z. Take z to the other side of the equation. You see that y is equal to minus z. And that is equal to minus, already here, what's the value of z? Minus half. Minus half. So y is 1 over 2. Minus times minus is plus. So we have y as 1 over 2. Okay, we are done with x. No, we are done with z. We are done with y. So let's go and find the value of x. X is, of course, on L. We say 4L. On the left, L is raised to power 0 equal to, on the right, L is raised to power x minus 3y. Their bases equal, their powers equal, we need their bases. So we have 0 equal to x minus 3y. That means x is 3y, which is 3 times y is 1 over 2. So x is 3 over 2. So we have x as 3 over 2. Guys, we've been able to achieve the values of x, y, and z. Simply, this is what we're asked to do. But there's something else I can just want to show us, guys, okay? You can actually from here rewrite the true expression as given. T equal to k a raised to power x, y raised to power, rho raised to power y, and tau raised to power z. So this is k. X is 3, a raised to power 3, now raised to power 1 over 2. You know, it's the same thing. So rho raised to power y is this, and tau is minus half. This is actually the same as this. A raised to power 3. Any number raised to power half means square root times another square root times, this is 1 over tau raised to power square root times 1 over square root of tau. This is what. Now you can try and make the whole expression a bit cleaner by saying this is a raised to power 3 times rho, since this is dividing, all over square root of tau. Of course, this is the same thing as k, all square root a raised to power 3 rho over tau. So you can actually get this expression by substituting the powers. I hope this can help someone. Of course, if you have any question and any contribution, anywhere we could have done it better or easier, guys, please feel free to contribute, comment, and recommend the page for other learners to join in. Thank you.